All right, everyone, it is now 3:30, so we can get started. Welcome back to another lecture for 426 Modern Web Programming. This is lecture 15. So hope you all had a great weekend. We're going to get started with some announcements like usual. So you all probably saw my message last night. So A04 Pokedex was extended 2 more days. So that allows you all to be able to ask more questions office hours if you need it. And also, I know there's a lot of things that are happening Monday, Tuesday of this week in terms of midterms for other classes and assignments. So I wanted to give the extra time. So in total, though, with that extra time, the assignment should have been open for just under 2 weeks. So hopefully that should be helpful. And then also the reading 6, which is talking about some of the things that we'll actually kind of be discussing in class today. That is due on Wednesday. Now remember, officially it's due at Sunday at the end of break, so you have extra time to work on it. But also that has been open and for about 6 to 7 days, so a week. So hopefully, if you have some time in the next few days, you can submit it so you have nothing to do over break. All right. In addition, for those of you who went to Hack-NC over the weekend, amazing work. There were amazing projects there from a lot of different people, I believe some of which were in this class. I was unable to kind of compile the list, but if I have it for next week, a list of the different projects, I'll definitely shout you out. And in addition, though, who I can shout out, so thank you very much to a few of your classmates who actually helped run the event on the kind of as part of the leadership of Hack-NC. You all did an amazing job. So big congratulations. It's a very big accomplishment to be able to host such a large event, student run here on campus. So terrific, terrific job there. All right. With that being said, we can get started with the content for today. So again, as a little bit of a recap from last Thursday when we last met, we introduced this idea of databases, particularly relational databases, which are used to essentially store information store information for our project. In addition, we kind of left off by talking about this idea that this database, right, stores our data in tables, and we can perform different operations on this database, such as reading data out of it and also modifying data. We typically abbreviate this as CRUD, so CRUD operations, right, creating new entries in a table, reading items in a table, updating existing items, and also deleting items. So you can see that this is the relationship that we're going to be working towards as we continue building up our tool set in this class and go toward future assignments, where your application will be able to interact with the database so that data can be stored long-term, and you can access it, for example, on different devices and share data between different users, etc. Right? One other thing that we mentioned last time, although very, very briefly, we didn't really get too much into it, was this idea of SQL. So SQL, it's abbreviated, right? SQL stands for Structured Query Language. SQL is what we call a little language. So a little language is just any programming language that is kind of made for just one very narrow specific purpose, right? Unlike Python or C or JavaScript, where you can do many things with it, right? These little languages typically have only one task. In this case, SQL's one task is to be able to interact with a database. So you can see here, I have an example of a SQL script. And of course, in this class, and something we're going to be working to, we're not going to be teaching pure SQL, because that is something that you might learn in a databases class. And it's also, there's a lot of different considerations there that you end up working with. Although it's helpful to know what SQL can do. Right, so for example, this is a sample SQL script. So the idea is that you'd write some SQL, which would be text like so, and then you give it to a database, and it will perform some operation on that database. In particular, what this particular snippet does is we are selecting 3 columns from a song table. So you can imagine that we'd have some sort of song table like so. And you'd have maybe 3 columns, singer ID, title, and duration. And we're just selecting those 3 columns. And we're also applying a filter here. So we're saying maybe where duration is greater than 20. Not sure, maybe that's 20 minutes. I don't know if there's many songs that are 20 minutes long, but this would give us back then the 3 columns containing the songs that have a duration of greater than 20 minutes. Right? So the idea of this is you can see that SQL can be used for filtering data, selecting specific pieces of information that we need, and we can do this across many different tables. Okay? You also, not shown here, can have the ability using SQL to add or insert new rows, update existing rows. All of those CRUD operations can be performed using SQL scripts. All right? Any questions so far with kind of our high-level idea of databases, CRUD operations, and SQL here? Great. OK, again, the point is, right, I'm not asking you to learn what this is saying. This is just an example of one of many potential SQL scripts that you can have. But I want you to kind of pay attention to the fact that this is kind of like a programming language script. It is written out as text-based. So this is a text snippet that we would pass to our database. Okay. And of course, this presents us a problem in the context of working in our projects. Right? So SQL is a language dedicated to just interacting with databases. Right? Except as I mentioned in the previous slide, right, these SQL scripts are it's just text, right? It's just a string. And so you can imagine that from, let's say that we're trying to interact with a database from within our TypeScript project. Right? If we want to interact with a database, we would have to run a SQL script on that database. And essentially, we would have to pass in just a raw SQL string in order for that operation to happen. Right? Something very vaguely pseudocode-like, right, might be db.execute, and then you have some string like select all from some table. Right? So you can kind of see here that what our operation we're doing on our database is. This is literally just a raw string. There is no benefits of things like syntax checking or making sure that your statements are valid. None of that, because it's literally just a string in this case. And so we lose that. We kind of lose that functionality and that help as a developer there. And then another thing that's important to note here, and you'll actually have a chance to see this in the reading, because in the reading there's an example of this, where if you run a SQL script on a database, well, what you also get out is just a string format of the items in your database. So you would literally get a string back that might look kind of formatted nicely like a table that has a few rows in it, or maybe has one row. But that ultimately is just a string. And so if we wanted to do something then with this data in our TypeScript projects, we might have some issues, because we then have to read this string, manually parse it, get the right information out, et cetera, which can be a challenging process to do on its own. Okay. So again, kind of visualized here, you can see that from our project with just pure SQL, we would be providing along a string, and I kind of should have maybe put quotations around this to further prove, right? That's a string. This gets sent to our database, and then the database will respond back with also some string of some data. Okay? So for example, one thing that I might actually show here real quick, which I will do is, because I don't have it on the slide, but I want you to also see it, is here. So if you do see the actual reading, I have an example of what this string output might look like, right? So you can see that from a SQL database, you would get just a string with a bunch of formatting that shows your data, right? This is not in any format that's easy for us as a TypeScript developer to use. Okay? Any questions so far with this? All right. So again, the entire idea here is that we want to be able to use our database to store information, but we want to be able to do it in a way that's easy for us to do as a TypeScript developer, so that we're not kind of forced to work with and parse a bunch of raw strings out. We need a tool then in order to be able to interact with a database from within our TypeScript project so that it feels native to the programming language that we're using, in this case, TypeScript. Right? Except this class of tools also exists for other programming languages as well, because maybe from if you're working on, for example, an iOS app which uses the Swift programming language, you might also need some tool to be able to interact with a database, right? So even though we are building web applications in TypeScript, this particular problem is applicable very widely to other types of applications as well. And so this is where we introduce a special class of tools called an ORM. ORM, and again, I apologize, throughout the last few weeks, there's been a lot of three-letter acronyms for some reason. I think as computer scientists, we really like it. But Object Relational Mapper is the official name, except most people just call it by ORM. So if you hear ORM, that is the classification of tools that we're talking about. And all ORMs they are tools that allow us to interact with the database, but kind of within the native context of our programming language. Right, so what that means is instead of having to write pure, for example, just SQL scripts, which are in a text format, we can actually just call functions like regular functions that we would in TypeScript, and that would help us to perform these same operations. Right? So ultimately, ORMs are the bridge between the applications that we develop in our programming language of choice, like TypeScript, and the SQL database on the other side that we're ultimately using to store data in. Okay? And so the key point here and the main functionality of an ORM is that it helps us to convert between what we're doing in a TypeScript project and what maybe a SQL database expects in one direction, and then in the other direction, our database gives us back some stringified table of our data. Well, we want to work with, for example, objects in our TypeScript programming language. And so the ORM will automatically do that conversion for us. Okay? So again, this is kind of our approach with just SQL, where you have a string going in, that's our SQL script, and a string coming out, which is some data back, or some result from our database. And then with an ORM, you essentially are just calling TypeScript functions, and you receive back TypeScript objects. Right? So as a developer, the only thing you really have to worry about are these two pieces: calling the correct functions to interact with our database, and then also handling the TypeScript objects that we get back from the database. The ORM is responsible for all of this stuff. So this is stuff that you do not have to do manually. The ORM does, which is taking your TypeScript functions, converting it into SQL, and then taking that raw text from the database and actually converting it into nice objects that you can use in your programming language. Are there any questions so far? We're going to see a more concrete example in a moment. All right. So ORMs are a very, very powerful tool. And no matter what type of application you are building, whether it's a web app, whether it's a mobile app, you will often, if you want to interact with some database, you often will encounter or end up using some sort of ORM to make this process easier. In this class, we are going to be using an ORM called Drizzle. So Drizzle is an extremely popular ORM. It's written in TypeScript, and it's for the TypeScript ecosystem. Right, so the idea is that it allows us, again, to interact with a database from our TypeScript projects very easily. We can just call TypeScript functions and get back TypeScript objects using Drizzle. Drizzle it's again very popular. There's over 30,000 stars on GitHub. It's been up and coming over the last few years, and there's been a lot of development going into it. The reason why we're using Drizzle in this class is it's, one, very performant. So it's extremely, extremely fast. It does the conversions back and forth in a very efficient way. And also, it's very easy to use. The APIs and the documentation are pretty clear, and that makes it very nice for us to use. Now, if any of you have kind of done anything with web development before, you may have heard of Prisma, which is another ORM. The main difference, though, here, and this is just for those who are interested, because if you look online for a TypeScript ORM, you'll hear these two names. And the question often comes up is, which one should I choose, right? So in this class, and you can use this logic kind of even no matter what type of applications you're building as you're choosing what tools to use. but Prisma uses a more proprietary way. They have their own .prisma files that you have to manage. Here with Drizzle, everything is in TypeScript. So it's the learning curve, especially for a class like this, is pretty nice. And so we'll go here to the website for Drizzle so that you can see it. And you'll see that this is the home page. Once you get there, you can see it says ORM, right? That's what we're talking about. You can see that it's for JavaScript and TypeScript. And there's a lot of details in here that are pretty nice, right? So you can see performance is extremely good. In fact, here they have a comparison between Drizzle and its competitor. You can also, another thing that's very useful to know here is that even though in this class we are using a PostgreSQL database, there are many different flavors of databases out there, as you can see, for example, MySQL, SQLite, right? So ORMs can connect to multiple different types of databases. So it's a wide umbrella. So no matter what you're using, if you're in another project using another type of database, well, you can still use this class of tools as an ORM. And then in addition, and I think there might be some details here, maybe in the documentation section, right? You can see that in order to essentially perform operations such as selecting all of the rows from the countries table, you do that using TypeScript functions, right? You have a DB object, and then you have .select, which selects columns, .from, it's a certain database table, right? Which makes it very, very nice, very nice to use. Trying to see here if there's another example. But ultimately, you do not then have to write pure SQL in a string, right? You can use actual TypeScript functions. There are really nice features as well because we are using TypeScript, which is a statically typed language, right? We have type annotations for all these things. So this particular query here, if you run this, you'll get a result that is a TypeScript object, and you know what that type actually is. So you get to see what are the fields, what are the different properties, et cetera. What are the data types associated? All right, so this is really, really nice. If you were just using a pure SQL string, like for example, up here, you would just get back a string, and you'd have to be responsible for figuring out what that string actually represents. But using an ORM and a tool like Drizzle, this is all nicely typed. And so we take advantage of TypeScript's type system very, very nicely. Okay. Any questions so far? So if you have not already started the reading 6, reading 6 does help. And also let me jump to the slide that we were on here. There we go. So in R06, you are probably learning about Drizzle. You've had the chance maybe to play around with it a little bit, calling these functions. So the point of the reading is just to get you a bit familiar and just practice using these different functions that exist in Drizzle. Because again, using these type of tools, a lot of ways, the best way to kind of get more familiar with it is to practice, and not just reading the documentation, but actually using it. And so this particular reading, there's a section where you're just going through these challenges. Like it'll ask you maybe grab, like if you have a table of cities, grab the city of California from the database, et cetera. So it's just interacting with a database using Drizzle. And this is going to be a tool that we will be using throughout the rest of the class to build much larger and more feature-rich applications. All right. Questions so far? All right. So again, just this is a little bit of a reminder from last time. I know there was a lot in last lecture with databases. So we're trying to pick different pieces from there as we go along. But I do want you to remember, right, that just like regular servers, databases are hosted on some server somewhere on the network, right? Databases are accessible on the network, which is how applications are able to interact with them. Remember that on Thursday, I kind of mentioned this idea of this database URL, which you can see here in this string. The database URL is just the way that we are able to connect to a database on the network somewhere. And so it typically has, and I believe that this is still, I copied this slightly. incorrectly. So this QL is not supposed to be in there, but it would look something like this. So we have Postgres, and then we have the username and password for our database, and then where the database is located, which is this host and port, it's an IP address, and then the name of the database. So using this URL, we're able to connect to the database and then perform operations on it. Right? And so when we're using an ORM like Drizzle, right, Drizzle needs to connect to the database so that it can perform the operations that we request of it. And so you can see that actually with Drizzle, just one line of code here, db equals Drizzle, and then we pass in the database URL. This is enough to get started to have a reference to our database for us to perform operations on. And so you can even see in the in reading 6, you will have the ability to see this where you take a database URL, pass it into Drizzle, and then from there you can perform different operations. Right? Questions so far? Great. So really all this is, again, this is just showing you that, well, we have Drizzle here. We need to be able to connect to the database somehow. And so to do that, we give it the database URL so that it's able to perform these operations. All right. There is a very big problem with this, though. And this is kind of hidden maybe in this diagram, something that ends up actually being an extremely, extremely severe and critical issue with our setup. And so what I would like you to do, this is also the attendance check for today, is to, and we'll give more than 2 minutes. We'll give around 5 minutes. I want you to really think about where there might be an issue here. So we'll start off with 2 minutes, and then I'm going to kind of give a hint as to what you should be looking at. I just want you to I want you to really think about this deeply as to where this could be a critical issue with this particular diagram. I'm going to start you off with very little to work with for 1 to 2 minutes. Then I'll kind of mention what you maybe should be thinking about, and then we'll give another 3 minutes, and then we will come back together and discuss. All right, so again, here the hint, I want you to think about the security of this particular arrangement and what security implications might come out with our diagram kind of set up this way. So we'll give another 2 minutes to continue to think about this, but I will provide the secret word now, which will be maple, all caps, like so. All right, everyone. So I think it's been a decent amount of time. Definitely put your thoughts in. Remember, there's no correct answers on the, or there's no incorrect answers, rather, on the attendance check. So this question is mainly just to get you really thinking about what's going on here. Does anyone have any thoughts about what might be looking incorrect? Yeah. Computer science intern approach where you like password to the database with your username if they like look through. Yes. And you don't want to give them like admin or whatever, like special access to your proprietary database. Yeah. Exactly. Yeah. So there is some exposure here regarding kind of connecting to our database because we have this database string here. Does anyone want to add, or does anyone have any ideas on how to add on to that in particular? So I think that's definitely on the right track. Yeah. Right. So, and why wouldn't we want it to be, or why would it be a problem if it's on the client side? Yep. Yes, exactly. So I want to show this in the context of the diagram because I think this will help understand what the issue is here, right? Because if we released an app like this, there is a severe vulnerability such that somebody would be able to hack in and have direct access to your database and be able to perform any operation on the database, right? Why is that the case? Let me hide this. There we go. Right? So remember how we load our websites. This is going back all the way, again, back to the lectures with these diagrams of loading HTML and JavaScript, right? So we have here, like this is our server that stores our web files. We have our client side. Here we just have a third kind of server, which is our data server. So this is our database. And so whenever we request a website, right, from the client side, the server responds ultimately with some combination of HTML, CSS, and JavaScript, right? That is the standard approach. And so you can see here that then on the client side, we have all of those files, HTML, CSS, and JavaScript. And what would happen here, right, is that all of our JavaScript functionality, all of our JavaScript code will run, which causes all of our functionality to get started. So this is React, the router, Next.js stuff, and also Drizzle. Right? So you can see everything is now running here on the client side, and Drizzle can then connect to the database with the provided database URL that we have. So this allows us to, right, perform operations on the database. The problem is, though, is where is that database URL actually stored? Right? And the problem here is that because we are using Drizzle, we have that code to connect Drizzle to our server, all of that information, including the database URL, is now sitting in the files that have been downloaded by your browser. So if you're able to look at the JavaScript files, for example, in the network tab, as you said, in your browser dev tools, you would actually be able to find the database URL for your project just sitting in there in that code. And so if somebody was able, if they wanted to try to hack into your database and you happen to architect your app this way, they can look through this JavaScript code here, find that database URL, and then just use it as they wish to perform any operation, read any table, change information, etc. Right? So it is true that because of the way that we had architected this, where Drizzle is running along with our code here, we have a severe vulnerability that happens with and exposes our database to malicious actors, right? And so again, this is catching up now to what I was saying, right? There's the direct URL to access the database is sitting in that bundle. And so anyone would be able to then have access to our database, right? Which is not good. And so ultimately, we need to modify our setup so that we protect the direct access to our database. And there's no way that the client can just look through their code and find this database URL and then perform different actions on it. All right? Any questions so far of just identifying the problem here? And so again, this is one of those things where this required, especially that question, if you did think through it and got an answer, right, required you to really have an understanding of how all of these things work. So no worries if you weren't able to get there. It's just one of those things where as you're developing applications, these are things that you do have to think about, especially security in larger apps, right? So remember, right, that Next.js is capable of running some code and some functionality on the server. We know that this is possible because of things like server-side rendering, right? Where our next project here in the server renders our HTML. It's running some JavaScript, TypeScript functionality. And so we can take advantage of this where our server is able to perform operations and run code whenever we make a request. For example, when we request a website, we do some operations and then we give an output back. We can take advantage of this and move and kind of make this even more powerful, right? What if the server here is responsible for performing these database operations? Right, so the idea is that we move Drizzle out, we move kind of our direct connection from our client out here to the server, so that whenever we download our website or whenever we make a request for our website, we do not have a direct connection anymore in our client-side JavaScript bundle. So there's no security issue. Everything would run, any database operations we wanted to perform could just be run by the server, right? So how would this happen? Right, you can see here, the idea is that the server is then given the database URL, and the server is something that you own, or it's kind of run by you or a trusted source. So it's not going to get leaked out anywhere. It's not that any random person can just get the website and see it, right? It's protected behind the server. And so then that database URL which allows this direct connection, is not ever going to be exposed to the client. Right, so the database URL would live somewhere over here. And so you'd only be able to connect back and forth like this. And your code here would not have that database URL. And so there's no way that someone would be able to recover your access, your direct access to the database. Right? And so remember that now, if we're doing it this way, where we're saying that let our server handle these operations, well, we need some way for the client to be able to initiate, right, one of these operations. For example, if I am creating a to-do list item in my app, I want to be able to then tell the server, hey, I want you to create a to-do list item and run this database operation. Right, so we need a way to tell the server that this is something that we want to do. And we can do this using this idea of APIs, okay? Where basically the client code, so our client project, will make a request. Just like how in the past we've made requests for different resources, we can just make a request to the server and say, I want you to do some sort of operation. Then the server can take that request, do that operation, right? For example, perform some operation on the database, and then it can respond back with whatever was requested. So for example, if my website, I'm requesting a list of all of the products maybe on my site, maybe I'm a seller of something, let's say, I don't know, water bottles. We're selling water bottles. I have a table for it. Well, I can make a request for it. The server will find that information by performing an operation on the database, and then it will respond with data, that data being the products that I am selling. All right? And so whenever we perform these HTTP requests, or whenever we perform network requests, right, we can actually provide more information about the type of operation that we're trying to perform. There are 4 different ones, right? So we have get, post, put, and delete. That's the typical lingo that we use to describe these things. But they correspond directly with these 4 different CRUD operations that we would do on our database, right? So get is equivalent to reading data, right? I'm trying to, for example, get a product list. I will read my database for product information and then display it. Posting is the same as creating, right? This may seem unintuitive, but if you think about it in the sense of like a social media app where I make a new post, it creates a new post. That's kind of that's the same terminology there. Okay. Putting new data. So putting is the one that always confuses people a little bit, but putting is just updating an existing record. So for example, if I have a product listing and I want to discount the price, I might make a put request to modify that item. And then delete is just deleting. So that one is relatively self-explanatory here. Now you have been doing this in your different exercises, perhaps without really knowing it per se. But for example, what you're doing right now, whenever you make a request to get Pokemon data, that request is going to some server. That server is reading a database, and then it gives you back Pokemon data, right? So you have been doing this already of making a request for some data. You just haven't been able to see what's on the other side, right? But this is the same idea. You also did this in A03 New York Times games. For example, in generating a random Wordle word or a connections game, right? That was a request you made to a server to get that data back, and the server gave you that data in JSON format, right? So it's the same type of idea. Yeah.
Does the server have to log in to the database every single time, or does it have like a connection established?
Good question. So yeah, there are ways to make it, there are ways to optimize it. So we haven't necessarily gotten here yet, but there is kind of the idea of, for example, like in 301 with a singleton, where you pretty much have only one instance at a time. So when your server starts running, you might create one open connection to the database and then just keep it there. And then every request would use that one connection. Yep. Very good question. Any other questions so far? Right. There are more that you have done already with getting information, again, with connections, et cetera. It's the same idea. We're just making, but instead, right, with these, where you got Pokemon, you got Wordle, you just made the request and got some data back. You didn't actually handle the other side, right, what the server actually did. You didn't write that code, someone else did, right? But now we can begin to think about how we might be able to actually respond on the server side to requests. And again, I have a note here, right? So we've been doing this already with the fetch function, making these requests. And we can now define what the server actually does when it gets one of these types of requests. And so this is what you'll be able to begin seeing after fall break once we get started with the next assignment once, on the other side of break. Okay? Questions here? All right. So we have these three levels now. We have kind of our client side that makes requests to some code running on the server, and then the server is interacting with some database, right? And so this particular diagram here is a very important diagram for kind of building full stack applications and in general software engineering. We can begin to simplify this down where we just have these three levels. And now terminology that you have maybe heard quite a bit before comes in, where the code that typically runs here on the client side is often called the front end of the application. So client side and front end kind of go together. Code running here on the server is typically called the back end. So you have server side code, back end code. These are synonyms. Right, so your front end can make requests to your server code, to your back end. The back end can then respond to the front end, like so. And then finally, the third piece of this diagram is what's known as the data layer. So the data layer is just referring to maybe any databases or other storage information, or maybe some other server that we need to access to store data related to our application. Right? So these three pieces, front end, back end, and data layer, this is known as the three-tier architecture, right? So with software engineering, this is kind of one of the most fundamental concepts of how we architect our applications. And the truth is that there are entire jobs and entire careers dedicated to just these different parts. Right? You could be an engineer working on mostly front-end things. You could be an engineer working on just code running on the server side. You might even be one of the engineers working on that database layer. And so in the real world of software engineering, these are really big, these are very big pieces, very big careers themselves, each of these. And so it's when someone says, for example, front-end engineer, back-end engineer, you can kind of begin to relate that to what they might actually be working on or what they might be doing. Right? Any questions here? All right. And so the next assignment after break, you will actually be writing server-side code. So you'll be writing code here that'll run on the server. In particular, you actually will be recreating a social media application like what Twitter maybe used to be or something like that. We can make posts, post images, follow accounts, post different things. So that'll be what we'll work on at the kind of next part after break. And so you'll begin to use Drizzle. You'll begin to explore this idea of making requests and responding to requests from the backend side on the server. All right. Now, we've kind of talked about these two things already, where our client side is just code running. That's Next.js, right? Next.js code. And we've mentioned that our client is essentially the browser. And then here, your development server is typically running on Vercel. That's what we've been using so far. Vercel is what's responsible for running your project. And so the question now is, well, how do we actually set up this third piece? Because the third piece, like our actual database, we've not talked about yet of how do we actually set up a database and be able to then connect to that database, right? And so there are different ways to approach setting up a data server. You could do it manually and basically run everything on its own and on a server somewhere, and that's totally fine. A lot of applications do that. There are also those special providers called backend as a service, BaaS providers, that help manage the data platform for you so that it essentially gives you access to a database that you can connect to, et cetera. And so many large projects may outsource such management to one of these providers. And there are good reasons to. It can lead to, for example, faster development. You do not have to worry about kind of managing all of that workload yourself and setting up a server, getting a database running, and all of that type of infrastructure. In addition, oftentimes, if you're one person doing it, you may be prone to making a mistake and making it break in some way. But if you rely on a provider which is well known and is much more reliable, then it helps your application because then you don't have to worry about things going down because of a mistake you made. Right? And so this is very good because, again, as a developer, especially if you're working on a project on your own as like a more solo developer, a smaller team, this makes it makes it easier to be able to build applications with features that, for example, use a database, et cetera, in a way that is much easier than doing everything manually. And it can result in you being able to build your application faster and scale it at a quicker rate. In addition, not just databases, but BaaS providers often include many other services that make it really nice to be able to perform different operations. So for example, authentication. This is something very important. How do users actually sign in to your app and manage user data? That we'll be talking about after break. Things like file storage. For example, on a social media app, if somebody posts a picture or a meme or something, you need to store that picture somewhere in order to be able to access it, right? So storing files is a very important thing. Real-time updates are a big one. So for example, if you are in a chat room and you're sending a message to somebody, well, that you might want, right? You might want kind of a new message when a user sends a message to show up on your device very quickly. And so that's another thing that kind of real-time communication, multiplayer apps, or if two people are on the same maybe artboard, or Google Docs is a good example. If two people are typing at the same time, right, managing all that back and forth is also a very important thing to manage. And database providers, or sorry, BaaS providers can do that. And so there are many popular ones that might come up. Firebase is one that you may have heard of. And I believe that some clubs here at UNC use Firebase behind some of their apps. Firebase is pretty good. It's managed by Google. It's pretty reliable. There's a lot of different integrations that it works with. So it can work with a web app with TypeScript. It can work with an iOS app with Swift, or a Kotlin Android app, et cetera. The drawback, though, here, the main one with Firebase is that the database that Firebase gives is a document-based database, meaning that it's essentially storing a bunch of objects in these different pages and in different folders, which is not the same structure as a relational database that we've been talking about with tables and all that kind of stuff. And ultimately, having a relational database is a very, very powerful and useful thing to have, which we'll see as we go throughout the course. And rate limits also slightly more restrictive in the sense that the number of read and writes is something that they track, and if you hit a certain amount, then they will not let you do anything unless you pay them. You know, the typical model of the business, right? Also, there's other ones like AWS has some. I believe that this particular one, AWS Amplify, also has a similar setup to Firebase. It doesn't use a relational database. AWS, though, has options where you can have a full-on Postgres database as an option, but it's something that does cost quite a bit of money to get set up. And so the one that we're going to be using in this class is called Supabase. And Supabase is actually really, really nice. It is very reliable and it has a lot of the same features that Firebase from Google does, except it actually uses Postgres as the underlying database. So it's really nice. It gives you a full Postgres database. You have full access over it. In addition, free tier is very generous. There's actually unlimited reads and writes, which is great for an academic environment like this one. If someone writes a runaway for loop, for example, by accident, and they won't use all of their limit in one day, which is nice. The only limit they have is like gigabytes of space, but in most cases, 2 gigabytes for a database is well more than enough. It can store millions of records, so it's not a problem. And it's also open source, which is really nice. Because if we wanted to ever say, you know what, Supabase is costing me too much money, I want to just run this myself, well, Supabase is open source. You can run it anywhere you want, and you don't have to just use their own platform. So there's no vendor lock-in, which is really, really nice here. Okay. And so what I would like to do here is just to show around the website a little bit here of Supabase to kind of show you what features they have. So I'm going to open this up, and you can see they have a lot of different things, right? Postgres database, and let me see if I can fix the because I believe this is going to be too hard to see because it is dark mode here. So let's see if I can fix that. Well, I believe I am on light mode, so that's just the way that it will be. I'll try and zoom in here a little bit because it's pretty bad. Let me see if actually this drop down, let's refresh here. Okay. Well, the text is white, so maybe it's all right. So you can see here, right, things like database, authentication, storing media, these real-time event broadcasting that we talked about are all things that Supabase provides for us. And we're going to be able to utilize all of these things to build very complex applications over the course of this class. If you click on things like the database, right, you can see just Postgres. It's a Postgres database. You have full access over it. I'm going to show an example of it in a second. And also, though, one thing that's really nice is if you go to the documentation, which this is in light mode, so it'll be easier to see, you can see that it works with a whole bunch of programming languages. So JavaScript, TypeScript, which is what we'll be using. But if you're building like a Python app, you can interact with this using Python, Swift, Kotlin, etc., which is very, very nice. I want to show, though, an example of an actual database, or sorry, an actual Supabase project. So the way that this works is you would create a Supabase project, and that project will contain, for example, database, user authentication, all of the things that you'd need. And so as you can see here, if I go to the side, you see that you have access to, for example, a tab for database. And in my example project here, I've actually created 2 tables. And so what's really nice is that you can actually see when you create your tables, a very nice diagram, very similar to the one that you all were drawing out by hand last Thursday. Right? So you can see I have a songs table and an artist table. You can even see that I have a relationship between the two. Right? So I have a foreign key from artist ID to my ID. Right? So this is kind of the same setup that we had last time. It's also very nice because you can click on table editor and actually see your data. So you can see in my artist table, I have two rows there. And then in my songs, right, I have a row for Citizen Blues is the name of a song. And you can click even to see what artist I am related to. So you can click right here, and you can see that it looks like I was the one who released this song, right? So it's really nice because you have a visual, a way to visually edit your database to see what's going on, which is quite nice. And in addition here, I will be deleting this project later. So even though I'm about to reveal some secret information, no one will be able to exploit it in any way. There is a link here to actually be able to, and actually maybe it's fine because the password is hidden. You can actually see the database URL to be able to connect to your database. So you'll notice here that we have these different tabs. And so if you press on the ORM tab, it actually gives you, and so we have different tools like Prisma and Drizzle. So we're using Drizzle. And you can actually see right here that it gives me the database URL to access this database. So I can take this URL, put it into Drizzle, and then I can interact with my database using the ORM. Right? And you can see it has all of the same type of thing. We have Postgres. And actually, this one uses Postgres SQL. So maybe my slide was correct. Right? We have the name, or sorry, we have the user for the database, the password for the user, a host, which is this supabase.com, and then a port, and then the name of the database. Right? So all of these things are here, and it makes it very easy for us to interact with our database. For example, they actually have, right, some example code with some more advanced things in here, like we moved our connection string out, we pass it in. And then ultimately, you can see just like that, we can then interact with the database using these database commands. So that makes it very, very nice. Right? Are there any questions here at all? All right, so Supabase is something that you will be able to, we'll be playing around with quite a bit in the next, again, in the next assignment. So I just recommend, right, looking through kind of that the drizzle reading, kind of getting a bit familiar with those database operations. And then from there, as we move into the new content after break, it'll be very easy for us to take this Supabase database, use this database URL, connect to our project, and then interact with our database to do some pretty cool things in our apps. All right? Any final questions? All right, so with that, I hope you all have a great break. We can finish 15 minutes early. If you have any questions, we still have office hours also tomorrow on Wednesday, so definitely feel free to come to that. And we'll see you all next Tuesday in here, Haynes Art Center.